Hello everyone, I am Sibendra Singh. Today I'm going to discuss a question from Test of Maths at the 10 plus 2 level. It's a question number 152 of subjective type. It is also a past year question of ISI B.Stat or B.Math entrance examination. The topic is limit of sequence. The question is as if a naught and b naught are any two positive integers and a_n and b_n are defined for all n greater than or equals to 1 using these two relations. Also cn is equal to an by bn for n is equal to 0, 1, 2, dot dot, right? So we need to find root 2 minus cn plus 1 in terms of root 2 minus cn. Part A, root 2 minus cn plus 1 is equal to root 2 minus cn plus 1 is n plus 1 or bn plus 1, right? Because it holds for all n, right? So an plus 1 by bn plus 1. And what will be an plus 1? It will be an plus 2bn, right? So root 2 minus an plus 2bn divided by what will be bn plus 1? It will be this way, right? So an plus bn. On simplifying this, we get root 2an plus root 2bn minus an minus 2bn divided by an plus bn. We take root 2 an common, root 2 minus 1 times an minus root 2 times minus root 2bn times root 2 minus 1, correct? Divide by an plus bn. So this will be root 2 minus 1 times an minus root 2, sorry, here it will be bn. bn divided by an plus bn. So on dividing by bn, we get an by bn minus root 2 will divide by an by bn plus 1, and this is cn. This will also be cn minus root 2 divided by 1 plus cn. This can be written in principle root 2 minus cn divided by 1 plus root 2 minus root 2 minus cn for all n greater than equals to 0, right? So this is root 2 minus cn plus 1, root 2 minus cn plus 1 in terms of root 2 minus cn. Okay, so this completes our first part, and in second part it is asked to so that root 2 minus cn plus 1 mod is less than this thing, right? So let's begin. B part, we take mod of root 2 minus cn plus 1 by root 2 minus cn. This is equal to 1 minus root 2. We substitute this uh, as we found here by root 2 minus n divided by, instead this looks so complicated, so we write the simplified version as it was. Okay, this divided by this thing, so in denominator this will be root 2 minus cn, so we can cancel this. This will be root 2 minus 1 by mod of 1 plus c1. This will be by root 2 plus 1 times 1 by mod of 1 plus c. Now we will show that this quantity will always be less than 1. Okay. Uh, we show we will show 1 by 1 plus n is less than 1 for all n is equal to 0, 1, 2, dot dot. We know we show this by induction. First, for n is equal to 0, we know a naught is positive, b naught is positive as given, right? So a1 is equal to a naught plus 2b naught is greater than 0, and a2 is equal to a naught plus b naught is also greater than 0. Sorry, this is b1, right? Let me write clearly. Right? So c1 is equal to a1 by b1 is positive. This implies 1 plus cn is 1 plus c1 is 1 plus c1 is greater than 1, or 1 by 1 plus c1 is less than 1. So it's true for n is equal to 1. Let it be true for k is equal to 1, 2, dot dot n. In fact, it will be true even for 0. Uh, so an will be greater than 0, bn greater than 0. This can be observed by induction hypothesis. Then cn plus 1 is equal to, we have been given an plus 2bn by an plus bn. So this is positive, so this is positive. As a result, 1 plus cn plus 1 is greater than 1, or 1 by 1 plus cn plus 1 is less than 1. So by induction, we came to the conclusion that this thing holds for all n is equal to 0, 1, 2, dot, dot, dot. So in the previous phase, we observed that this quantity is always less than 1. So this will be less than 1 by root 2 plus 1. Therefore, mod of root 2 minus cn plus 1 is less than 1 by 1 plus root 2 times mod of root 2 minus cn for all n is equal to 0, 1, 2, dot, dot. So this way, part B is done. Now in C, it is to show limit n tends to infinity cn is equal to root 2. So we begin here. We have been we have already observed that root 2 minus cn by root 2 minus cn minus 1 is the mod of this quantity is less than 1 by 1 plus root 2. So instead of n, if it is okay to put here k, because we will assume k is greater than equals to 1, and then what we'll do is we'll take the product from k is equal to 1 to n. So this will be, this bracket is not necessary. Root 2 minus ck by root 2 minus ck minus 1 is less than product of k from 1 to n 1 by 1 plus root 2. So if you solve this, you will get root 2 by root 2 minus cn divided by root 2 minus c naught. This is some telescopic type. So it's a product, right? This divided by 1 plus root 2 whole to the power n, right? So here will be modulus sign as well. Let's not forget that. Mod of root 2 minus cn will be mod of root 2 minus c naught divided by root 2 plus 1 whole to the power n, right? So we were asked to find limit at tends to infinity cn. So let's see. Observe that this thing is always greater than equals to 0, right? And this is valid for all n is equal to 0, 1, 2. Uh, let's put so. This will also be valid for n is equal to infinity. I mean, when n tends to infinity, uh, 0 less than equals to limit n tends to infinity mod of root 2 minus n is less than limit n tends to infinity root 2 minus c naught divided by root 2 plus 1 to the power n. Uh, Root 2 minus c naught is a finite number, and this tends to infinity as n tends to infinity. So this will be 0. So by sandwich lemma, we can say that. Let's write our next piece. Limit n tends to infinity mod of root 2 minus n is equal to 0, which implies that limit n tends to infinity cn is equal to root 2. So this is part C. And our problem is solved. So thank you. Have a nice day ahead.